Good morning. Good morning. All student came. Okay. So I was, I think I was discussing some problems. Okay. So mixing of the two gases and what is the final pressure? Okay. 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 So do some more questions. Then we will come to the graph. So suppose a gas is kept in container at 27 degrees C and 20 atmospheric pressure. If stand maximum pressure of 100 atm, then find maximum temperature up to which it can be heated. That is a simple question. So gas is kept in a container at 27 and 20 atmospheric pressure. If a container can withstand maximum pressure of 100 atm, then we have to find the maximum temperature up to which it can be heated. What is the answer? No answer. So which law we will use here? So first we have to see gas is enclosed in the container. So gas is enclosed in the container and container volume is fixed. So that's why we can say what? Volume of the gas will be constant. Volume of gas is constant. So here directly we can say, and no gas is leaking out. No, we are not adding any gas. Then we can say the mass of the gas is constant. So in this case, V is constant. So when volume is constant, then we can say what? P directly proportional to T. So from that we can say P1 upon T1 is equal to P2 by T2. Okay. So they are asking the maximum temperature up to which it can be heated. So we know that we can heat, when will we heat at constant volume, pressure will increase. Maximum pressure can increase up to the 100 atm, because beyond that what will happen? The container may get destroyed or break. So we can increase the pressure up to the 100 atm. Okay, so final pressure of P2 we can say 100. Initially they have enclosed the gas at 20. So P1 we can take, P1 is the 20 atm. P2 we can increase up to the 100 atm. T1 they have given 27, so that's why 300 Kelvin, and T2 we want to find. Then from that we can say P1 upon T1, put the values. So 20 by 300, that is equal to 100 by T2. So I think everybody is getting the answer, 500 Kelvin. Okay. So T2 will be equal to 1500 Kelvin. So if T2 is the 1500 Kelvin, then in the degree C, we can say what? 1500 minus 273. Then you will get the answer in a degree C. 1227. Okay, so maybe read the question carefully. Maybe suppose they can ask how much temperature we can rise. If suppose they are asking how much temperature we can rise, maximum temperature we can rise, then what will be the answer? Gas is enclosed at 27. it can reach up to the 1227. So how much rise is there? 1227 minus 27, that is a 1200. Okay, so maybe in the problem read it carefully. Okay. Okay. Next, if gas is enclosed in container of volume 30 liter and then it is heated its temperature is 127 degrees C. If some gas leak out, then pressure reduces by 0.5 into 10 to the power 5 Pascal. Then find mass of gas leak out. If at STP density of gas is 1.3 gram per cc. 1.3 kg per meter. So gas is enclosed in the container of volume 30 liter and then its temperature is 127 degrees C. If some gas leak out, then pressure reduces by 0.5 into 10 to the power 5 Pascal. Then find the mass of the gas leak out if at STP density of the gas I have given 1.3 kg per meter cube. So how will proceed? So here they have not given the initial pressure. They are saying only due to the leak of the gas, the pressure reduced by 0.5 into 10 to the power 5 Pascal. And they are asking the mass of the gas leak out. So by the ideal gas equation, we can calculate the how much mole has leak out. How much mole has leak out? We can find. And we can find how much mole has leak out. After finding the number of mole leak out, then we can say what? Mass leak out is equal to what? Mole leak out into the molar mass. But the problem is what? The gas name they have not mentioned. So we don't know the molar mass directly. So first aim is what? First we have to find the how many moles has leak out. Okay. After finding the mole leak out, now to get the mass, I need the what? I know the mole, then I need the molar mass. Mole into molar mass, I can get the mass leak out. Okay. So for that they have given the density data. For that density data they have given, we can calculate the molar mass from the density data. So first everyone will find the how much mole has leak out. Then who will say what we will do? So from ideal gas equation we can say what? PV is equal to nRT. Okay. So here pressure is changing, same container I am using, so volume is not changing. R universal gas constant, T temperature I am not changing, I am not heating it, I am just the gas is leaking out. So temperature constant, volume constant, R constant, only which quantity is changing out? Pressure and mole. So I can say directly delta P into V. Just apply the delta on both sides. So delta P is equal to delta N into R into 3. Yes or no? Now delta P directly they have given 0.5 into 10 to the power 5 Pascal. Okay. Volume they have given in the liter, 30 liter, volume of the container 30 liter, but liter is not the MKS, not the CGS. So liter we have to convert into the meter cube. So what you will put? 30 into 10 to the power minus 3 meter cube. Okay. So delta P into V. Everybody know that I said the conversion from the liter to the meter cube. Everybody know it? Okay. Okay. So delta P into V, that is equal to delta N. That I want to find. R value what will take? What is R value? We know the three values of R in the different unit. I'm using the MKS, so I have to use the MKS unit of the R. Who will say what is that R unit, R value? Which value will take? R is the 8.314. So 8.3 directly I'm just taking 8.3. Okay. Into T 127 degree I have given, so that will be the 400 Kelvin. So from that we have to calculate the number of mole leak out. So what is the answer? How many moles leak out? So if they are asking only the mole, from that we will get the answer. So delta N is the 15 into 10 to the power 2 upon 8.3 into 400. So this 0 and that cancel out. Then 15 upon 8.3 into 4. How 1.87, Priyanka? Check it again. Eight threes are 24, so denominator will be more than 24. I have to do 3 upon 5.1. 3 upon 5.1, so it will come less than 1. Okay, so I will do, no problem. So 8.3 into 4, so 4 3s are 12, 2, and 8 4s are 32, 1 33. So 33.2, and we have to divide by 15. So then you will get what? Decimal, then we can make here 0 and dot, then you will get 0. So 3 5s are 15, so approximately 4 you will take, 4 2s are 8, 4 3s are 12, 2, and 4 3s are 12, 1, 12, 2, 14. So that's 0.4. So approximately you will get what? 0.4. New answer came 0.62. 0.45. We can take 0.45. Okay. Everybody got or not? Otherwise, for this easy calculation, you can take 0.4. The process is this. Okay. Understood? Now, who will say how to find the mass leak out? So we got the mole leak out. So if they are asking the mole leak out, that is the answer. Now mass leak out, so we need the molar mass. How we will calculate the molar mass? So we will use the ideal gas equation again. D is equal to M by V. D is equal to M by V. Okay, what is the volume you will take? Density is the mass by volume. What is the volume you will take? 30 liter. Okay. And density? Density? Suppose you are taking the density, will use mass by volume. Density will take, volume will take, so mass you will get. So what the density you will take? 1.3. If density you can take 1.3, so directly then why we need this calculation? Directly density you know, volume you know, you can find the mass. But the problem is what? Density they have given at STP. Density they have given at STP, but here temperature of the gas is what? Temperature of the gas is 127. Pressure, I don't know. So density data they have given at STP, so we cannot use the density here. Everybody is getting or not? So why I cannot take the density is the mass by volume or mass is equal to volume into density? Because density data they gave at STP. Understood or not? And we cannot write any, we cannot use any law also here why gas is leaking out. Because mass of the gas is not constant. So somebody is thinking that, sir, volume of the gas is constant. then any law I can use. We cannot use law also because gas leak out mass of the gas is not constant. So that is the only process. First we have to find the number of mole leak out. Now from the mole leak out, we can find the given density, we can find the molar mass. Molar mass, how we can find? So we know the ideal gas equation, PM is equal to rho RT. Okay. Sahitya, number of moles is the molar mass upon given mass. Number of mole is the molar mass or given mass? Reverse you are saying. Number of mole is the given mass upon molar mass. First correct this formula. Number of mole is the given mass upon molar mass. But molar mass we don't know. So first we have to calculate the molar mass. So molar mass we can calculate from here. Okay. STP means pressure is the 1 atmosphere. 1 atmosphere approximately that I am taking 10 to the power 5. This M I want to calculate. Okay. And rho 1.3. Okay. Density they have given at STP 1.3. R value in the STP I will take 8.3. And STP temperature 27 degrees C means I will take 0 degree C, so that you will take 273 Kelvin. Okay. Now from that we can calculate the molar mass. One more twist is there. Who will say what is the molar mass value? Arey, you have the calculator maybe there. Calculate fast. Tell what is the answer. 863. Don't say the different answer. Somebody is saying 863.2 into 10 to the power minus 4, 10.8 into 10 to the power minus 3. Are say at least common answer. Same calculation you have to do. Molar mass is the 1.3 into 8.3 into 273 upon 10 to the power 5. That is not a problem. Only the multiplication you have to do. Calculated. What is the answer? 43. Now different answer. 43.16 into 10 to the power minus 3. Sure. Okay. I'll calculate in calculator. It will take time otherwise. 0.029. At least say one answer common. Everybody is saying the different answer. So that is a 1.3 into 8.3 into 273. 2945 or 46 we can take. (2946) into 10 to the power minus 5. Okay, now everybody got 2945 or 46 approximately you can take. That's not a problem. 2945 or 46. Okay. Are everybody got or not? Okay. Now then what you will do? Now after that what we will do? Molar mass we got. Molar mass we got. Now number of moles we know. So what we will do? Now listen, one problem, what twist is here. Here this mass capital M we are getting. I am using the PM is equal to rho RT. P I am using in the MKS. R I am using in the MKS. Okay, density I am using in the MKS. So this molar mass you will get in kg. This molar mass is in the kg. But in the formula of the mole, we take like number of mole is the mass upon molar mass. Molar mass we put in a gram. Then mass you will get in a gram. Getting or not? Because number of mole what we say. So if I am taking the mass in kg, then molar, basically like molar mass of the hydrogen is 32. Molar mass of oxygen is 32. So that is a 32 gram we take. Okay. Like to calculate the mole, we take the mass in gram upon molar mass. So we write as a 32. But here capital M we are getting in the kg because all unit we are using in MKS. So that's why here you will get in kg. So answer you will directly get in kg. You can convert this into the gram. After that, you can multiply with 10 to the power 3. But first answer you will get in kg. Everybody is getting my point or not? Okay. Now molar mass I got. So mass of gas I can say. In that there is a combination of the two problems. Okay. So different like this type of lengthy problem they will not give, but they can ask the part of the problem. Okay. So mass of the gas leak out is what? Number of mole leak out we got 0.45 or 0.4 you can take for calculation, and 2946 into 10 to the power minus 5. That you will get in kg, or you will get 0.45 into 2946 into 10 to the power minus 2 gram. Okay. So what is the answer you will get? Around 32 you will get. Okay. Pressure is 0. Total sum something. Okay. Pressure is the 0.5 into 10 to the power 5. What is the wrong in that? Somebody is saying some calculation mistakes. 13.5. Why 13.5? I wrote only 10 to the power 5, sir. I wrote 0.5, na? So 0.5 into 10 to the power 5, 30 into 0.5, that I write in 15. Density is the 1.3. Density also 1.3. From density. Oh. Okay, Gayatri. Now I got your confusion. That P I said I'm writing PM is equal to rho RT. What is the pressure there? What is the pressure there? Gayatri. What is the pressure I am taking there? PM is equal to rho RT, 10 to the power 5. This is not the change in pressure. Change in pressure in the above calculation I have taken. This is the what? At STP, what is the pressure? 1.01 into 10 to the power 5. That approximately I am taking 10 to the power 5. So that is not the pressure change. Pressure change already I have used. Getting my point or not? Here you are saying, sir, I am taking the pressure only 10 to the power 5 I am taking. So here I am taking the 10 to the power 5. That is the pressure at STP. So here basically 1.01, but for that calculation I took 10 to the power 5. Understood or not? This calculation am I using for STP. Density they have given at STP. Okay now. So people got the answer. Atmospheric pressure. Yeah, that is the atmospheric pressure. So I am taking for the fast calculation, I am taking 10 to the power 5. Okay, otherwise 1.01. They will give this data 1.01 or we have to take 10 to the power 5. Okay, now you will calculate. Any other anywhere problem? Okay. Any step? Answer maybe 13.2, whatever, I don't know. Okay then, okay, Abhiram, okay. Now at least some calculation you have to do. Okay. So now one simple problem. That is a lengthy problem. That was lengthy problem. So if the gas is at the temperature 27 degrees C and it has a 10 to the power 20 molecules per liter, then find the pressure of a gas. So pressure of the gas they are asking, temperature they have given, number of molecules they have given. So only one option we have for this ideal gas equation, PV is equal to nRT. So but N, what is the N here? N is the number of mole, but they have given the number of molecules. So first we have to convert the number of molecule per liter, we can convert. Okay. So P they are asking. So P I can write as N upon V into R into T. This N upon V is the number of mole per unit volume. Is N upon V, I can say number of mole per unit volume, but they have given the number of molecule per unit volume. So in a 1 mole of molecule, how many 1 mole, how many molecules are there? In a 1 mole of a gas, how many molecules are there? Avogadro number. So we can say what? Number of mole is equal to what? Number of molecule, that is a 10 to the power 20 upon Avogadro number 6 into 10 to the power 23. Okay. Samita, you are saying the pressure or what? Now P, what I can say here, 10 to the power 20, that directly I am writing as a 10 to the power minus 3 by 6. Okay. Volume I am taking in liter. Volume I am taking directly in liter. So this is a basically what you will get. N upon V, number of mole upon V, I can write as 1 by 6 into 10 to the power minus 3 moles per liter. Okay. So N upon V directly I got 10 to the power minus 3 by 6. But remember that volume I am putting in liter. So when we put the volume in liter and pressure in the atmosphere, so then R value we take as 0.082. Otherwise, first we have to convert this liter into the meter cube. It will be lengthy. Directly I can say what? P, if I am putting the pressure in atmosphere, volume in liter, then R value you will take 0.082. Okay. Atmosphere liter per mole Kelvin. So I can put 0.082. This is the R value because volume I put in liter. And remember that then pressure you will get in atmosphere. Getting my point or not? I am using P is equal to N by V RT. N by V I am writing number of mole per unit volume. Volume I am taking in liter. Then R value I will take 0.082 and then pressure I will get in ATM. If the answer they have given in Pascal, then we can convert atmosphere into the Pascal. Okay. Then into T what you will take? 300. Who will say what is the answer now? 6 5s are, so that you will get 6 5s are, so 50. Then P you got 0.082 into 50 into 10 to the power minus 3 ATM. Five 4.1. So that you will get P is equal to 4.1 into 10 to the power minus. Okay. If in the Newton per meter square or Pascal they are asking. Sindhu is saying the 4.1 into 10 to the power minus 4. So many calculations problems are there. 0 minus 3, 0.082 when you multiply with 50. Sindhu, what you will get? No. Are 0 and this will get 0.82 when you multiply with 10. 0.82 into 5 you will get more than 1. So how you will get the minus 4? Everybody got or not? 4.1 into 10 to the power minus 3 ATM. And if they have given the answer in Pascal, then multiply with 1.01 into 10 to the power 5. Calculation is a big problem. So when in the doing the studies calculation, do the calculation fast. Okay, then okay. 410 Pascal. If the answer they have given in Pascal, so you can convert into the Pascal by multiplying 1.01 into 10 to the power 5. Okay. Completed. Okay, now. So now we'll discuss some graph. So at constant pressure and mass of gas. So this is the condition of Charles law. So constant pressure and given mass, we need the Vt graph. So we know that V directly proportional to capital T, or we can write V is equal to C into T, where C is any constant. So graph will be the straight line passing through origin. Okay. Yes or no? Y is equal to V, you will replace by Y, T you will replace by X. So what you will get? Y is equal to Mx. Y is equal to Mx, a straight line passing through origin. Okay. Next, the same graph I am asking between V and temperature, but temperature I am putting in degree C. Temperature I am putting in degree C. If I am drawing with a Kelvin temperature and volume, I am getting this graph. If I am drawing between the volume and temperature, but temperature in the degree C, what will be the graph? What will be the change? Negative. Because then you can say what? Volume is equal to any constant C, and Kelvin you will convert into the degree C. So degree C plus 273.15, or sometimes in the 273 only they give. Okay. So when I put for the y-axis, for the x-axis, y must be 0. For the x-axis, y has to be 0. Y means volume and x means temperature in the degree C. Okay. So what will happen? The graph will shift on the negative. Why? When the volume is 0, if I put volume is equal to 0, then I will get degree C plus 273.15. So see what you will get? Minus 273.15. So at which temperature volume will be 0? Minus 273.15. So earlier it was started with origin here, because 0 Kelvin volume we consider as a 0. But here 0 Kelvin is equal to what? Minus 273.15 degree C. So graph will shift on the negative axis. Then graph you will get like this. And this point will be minus 273.15 degree C. So graph will be the straight line, but that straight line will start from the negative x. Should I repeat it again? Okay. Okay then, okay. So for the same condition, I need this graph. Rho and T, density and the temperature graph. What will be the graph you will get? For the same condition of the pressure and mass, pressure is constant, mass is constant. What will be the graph between the density and the temperature, absolute temperature? Rectangular hyperbola. Why? Because at constant pressure and mass, we will get the relation is what? V directly proportional to T, V upon T is equal to constant. But in this case, what we will get? Rho into T is constant. That relation you have written. Remember last class I said rho into T is equal to constant. So now here what you will get? Inverse relation is there. Inversely proportional. So you will get the graph is rectangular hyperbola. Okay. Everybody got? Now next graph you will say, same condition, here is the temperature, here is the Vt. What will be the graph you will get? Between Vt and T, what is the graph? Parabola. Okay, horizontal. Samita, horizontal. Trishal, parabola. Straight line on y-axis. Okay. Means a straight line. Somebody is saying horizontal straight line. Somebody is saying vertical straight line. Somebody is saying parabola. Horizontal straight line. Okay. So what I said, what graph they are asking. First, try to write the relation between those quantity. After that, you can decide what will be the graph pattern. Okay. So I don't need the VT graph. I need the VT. VT I'm plotting on horizontal straight line. VT I'm plotting on y-axis. T I'm plotting on x-axis. Horizontal line parallel to x-axis. Array, just listen now. Everybody is relating with the PV. PV and P graph. What we got? Horizontal line parallel to the temperature axis. So this is the different graph. Okay. Directly we cannot say there PV was constant. So here VT is constant. Here relation is different. Naveen, getting my point or not? So directly I cannot say PV was constant. In a Boyle's law condition, PV was constant, whatever the P and V value you have. But here the relation what we have, V upon T is equal to constant. Here VT is not a constant. Understood or not? Okay, then what is the relation at the given condition we have? V directly proportional to T, or I can say V is equal to any constant C into T. This is the relation we have from the given condition of pressure and mass. V is equal to Ct. But I don't need the V and T graph. I need Vt and T. So how I can get the Vt? So this relation I have, I want to get the Vt from this. So I will multiply T on both sides. So when you put the T on both sides, so Vt is equal to what? Ct square. I just multiply the T on both sides. Understood or not? So I got the Vt is equal to Ct square. Okay. Now Vt I am plotting on y. So which quantity I am plotting on y, that I will replace by y. So here I will write y. T I am plotting on x, so I will write here Cx square. So I got y is equal to Cx square. So this may be in the basic mathematics you have learned. When one is the power, one variable power 1, other variable power 2, so it is a parabola. Understood? Parabola, everybody know how to draw. So parabola shape is like this. Parabola shape is like this. Now according to the orientation, like here, cement, okay. So 4 parabola you can get. According to the orientation, the equation will change. Okay. So this is the shape of the parabola. Now if I am putting above, so equation is the y is equal to Cx square. If I inverted it, then equation will be y is equal to minus Cx square. If it is a open right means like this, then y square is equal to Cx. And if it is a open left, y square is equal to minus Cx. Maybe basic mathematics sir has said this. Okay. Okay. Otherwise, remember it, when you are getting the x square, one power is 1, one variable power 1, other variable power 2. So it means it is a parabola. Okay. Now in a parabola, if y is x square I am getting, so it will be symmetric about y. X square symmetric about y. Y square symmetric about x. Okay. Because parabola graph you will get so many places. So y square symmetric about x, x square symmetric about y. So here I am getting x square, so it will be symmetric about y. So how you will make? Okay. But negative Kelvin temperature will not plot. Maybe according to the option we have to think, and otherwise everybody know minus Kelvin temperature we will not draw. So negative part you will eliminate. So that's why graph will be this only. Understood? Should I repeat it again? Okay. So why negative part clear? Why I have removed? Because maybe in the option also they will not give the negative part. Otherwise, negative Kelvin temperature I'm not writing, so we started with a 0 Kelvin. Okay. And who will say, suppose these two graph, one graph they have given this, one graph I am giving this for the same problem. Which is the right answer you will take? Like one graph I am giving this. What is the right answer? This is the first one, this is the second. If the same condition of the pressure and mass, what is the answer we will take? 1 or 2? 2. 2 we will take. Why? Because it is a not first. We will take the second one, because here it is a like, if you take the image, it will get sharp image like this. But parabola is not the like sharp. This is not a corner. Here it will be like this. Okay. So first we will not get. What we will get here? At the one, it will has to touch the x-axis. It has to touch the x-axis. That's why answer is the second. First one, it is a sharp. Understood or not? So from the both graph, how you will differentiate in the VT graph, velocity time graph, maybe this you have done. When the initial velocity 0, when the initial velocity non-zero, what is the difference between them? This type of question you have done in kinematics. Why silence is there? Not understood. Suppose this is the VT graph we are plotting, or ST graph we are plotting. So which case initial velocity 0, which case initial velocity non-zero. So like this case non-zero, this case 0. So that difference means what? If they are, you have to draw the parabola at 0, x-axis has to be the tangent. X-axis has to be the tangent. Okay. So here x-axis is tangent. That's why answer is the second one. This is wrong. Okay. So just tell one very simple question. Find the pressure at B. Find pressure at B. So when we will get the P directly proportional to rho, here according to the graph given, it is a straight line that is a passing through origin. So we can say what? P directly proportional to rho. So P directly proportional to rho means P inversely proportional to the volume. That is a condition of the Boyle's law. Okay. So here according to the straight line, we are getting P directly proportional to rho. So we can say what? P by rho is equal to constant. Array, that graph we have plotted in a Boyle's law, P and rho graph. So P and rho graph, we got the straight line passing through origin. Remember? So directly, otherwise from the straight line, you can say P directly proportional to rho. So that's why P upon rho we can say. Sir, how can we decide that in the last question, upright parabola or turned? Upright and turned means like right or left. Then you will decide by the x square and y square. Like y is equal to something x square. So when you are getting x square, then it will be the open up. Minus x square, then open downward. Okay. y square is there, so y square is equal to cx, then open right, y square is equal to minus cx, then open left. Okay. Now in this case, p upon rho is equal to constant, then we can say what? P1 by rho 1 is equal to P2 by rho 2. So basically A and B, one I am taking A, B I am taking the 2. So what is the pressure I have given? P naught. Initial density 2 rho naught, that is equal to P2. It is a pressure at B. And what is the density I have given there? 5 rho naught. So rho naught and rho naught cancel out. What is the PB you got? 5 by 2 P naught. Okay. Completed? Okay. Now another type of problem in the graph. Suppose this is a V, this is a P, and two isothermal curve I have given. This is 1, this is 2, at constant temperature and given gas for two different masses. Suppose here mass I am taking M1 and here mass I am taking M2. What is the relation between M1 and M2? Means M1 is greater than M2 or M2 greater than M1. What is the relation between M1 and M2? M1 greater than M2, M2 greater than M1. Only two option is possible, and you are saying the both option. Okay, so how you will do this type of problem? Here, volume, you can take one line either perpendicular to volume axis or perpendicular to the pressure axis. Which quantity is constant? The line will be perpendicular to that. Okay, suppose I am taking the line perpendicular to the volume axis. Okay, so this line is cutting this point here. Suppose this is a 1 and this point is the 2. So this line is cutting the graph 1 at 1 and graph 2 at 2. Okay, so when you are taking the line perpendicular to the volume axis, so volume will be same, volume will be constant. And when you are taking the line perpendicular to the pressure axis, then pressure will be same. Choice is yours. You can take either the line perpendicular to the pressure or you can take line perpendicular to the volume. Suppose I take the line perpendicular to the volume axis. So volume axis means where it will cut the graph, that point 1 and 2, volume will be equal. So I can say here at point, otherwise you can write here A and B. So this point is A, this point is B. So I can say volume at A is equal to volume at B. But this two graph is for the two different masses. Now I know the ideal gas equation. Same gas given, same gas means molar mass is constant. At constant temperature means T is same. So this graph is plotted for constant temperature and molar mass. Okay. Now from the ideal gas equation I can say PV is equal to mass of the gas upon molar mass, that is the number of mole, into R into T. Okay, PV is equal to nRT, and I write the mass upon molar mass into RT. Okay, in this relation they have given the graph is plotted for constant temperature. Okay, R is universal gas constant, molar given gas means molar mass is constant. Okay, And on the line AB, on this line AB, volume is constant. On the line AB, volume is constant. Now you can see here V constant, M constant, R constant, T constant. So what I can say, P is directly proportional to M. Yes or no? So I will get what? P directly proportional to small m. Where the mass is more, pressure is more, their mass will be more. Now on the line AB, where the pressure is more, you can see here at the B pressure I am getting this, at the A pressure I am getting this. So pressure at B is more. Pressure at B is more. Now what is the mass at B? M2. So I will get what? M2 greater than M1. Everybody got or not? Okay. Okay. So next, same type of problem then you will do. Suppose this graph is plotted for the given mass but different gas at the constant temperature. Then what is the relation you will get? Suppose same graph I got for given mass of a gases. Minimize the screen. So what I am saying, same graph I gave for the given masses of a gas but different gases, given mass of different gases at constant temperature. Then M is constant, R constant, T constant, same line if you are taking, so volume constant, then you will say P inversely proportional to capital M. P inversely proportional to capital M. Then molar mass of gas 1 will be greater than molar mass of gas 2. Understood or not? So according to the problem, you have to think which quantity I have to take constant, then other quantity you can find the relation. Understood? Okay? Okay then. One more you can take, suppose for given gas and given mass at two different temperature, we can solve all the question. Yes, we can solve all the question like graph problem, all the question. Only one equation we have to use, ideal gas equation. Now choice is yours, you can draw the line perpendicular like this question. If you want, I will take the line perpendicular to the pressure axis. Which quantity you are taking constant, rest you have to think about that. Okay, all the problem you can solve. So here two different temperature, here temperature is the T1, here temperature is the T2. I am asking the relation between T1 and T2. So you want line perpendicular to the volume or perpendicular to the pressure? Volume. Okay. So you will draw the line perpendicular to the volume axis. So suppose it cut this point at B and this point at A. Then volume at A and volume at B will be equal. Now again we will use the equation PV is equal to small m by capital M into R into T. Now which quantities are constant? Mass of the gas constant, molar mass, same gas, so molar mass constant, R constant. Volume I have taken on the line AB, volume is constant. Okay, then I can say what? P directly proportional to the T. Okay, for this line on line AB, on line AB. On line AB, why? Because on line AB volume I am taking constant. Now P directly proportional to T. So where the pressure is more, their temperature will be more. Now you can see at A, at B. Where the pressure is more, at A pressure is more. So PA greater than PB. That's why temperature at A means T1 is greater than T2. Okay. Okay. Okay now. Now one just do the one VT graph. You have to find pressure relation. Find relation between P1 and P2. If this is a two isobaric curve like pressure constant, because we know that volume will be directly proportional to T when pressure is constant. So, but two graph I have made, so means pressure is constant. Two different pressure I plotted, the graph 1 and graph 2. V2 greater than V1. I am asking pressure relation. P1 greater than P2. Okay. P1 greater than P2. P1 greater than P2. Maybe everybody now understood. So now here you can take again, suppose you want the line perpendicular to the temperature axis. So you have taken this. Okay. So on the line, this is suppose at A and this is the point B. On the line AB, temperature is constant. Okay. So line AB, temperature is constant. Now again we will write the ideal gas equation. PV is equal to nRT. Okay. So given gas and given mass, that is given mass of a gas. This quantity I have given. So N is constant. Okay. R is constant. On the line AB, temperature is constant. Then I can say what? PV is equal to constant, or P is inversely proportional to V. So where volume is more, what is the significance of theta? Wait. So P is inversely proportional to V. Now where I am getting the more volume, at B I am getting the more volume. So means VB greater than VA. So pressure at A you will get more than pressure at B. A means P1. So pressure at 1 will be greater than pressure at 2. This everybody got or not? Okay. How we can use the theta also, or how they can give the problem based on theta. So suppose I am saying this graph is plotted for the 1 mole of a gas. This graph plotted for 1 mole of a gas. Then what is the pressure of a gas? If this graph is plotted for 1 mole of a gas, now I am giving the another problem on the same graph. If graph is plotted above and theta 1 is equal to 45 degree, then find pressure of gas. Then what is the pressure of a gas? Volume I am taking in a meter cube. V is in the meter cube and the temperature in the Kelvin. If volume is in meter cube. Now here how I will use the slope. So volume I have given, I am measuring the volume in the meter cube. So slope is equal to what? I will write the what I said, only one equation we have in this chapter. PV is equal to nRT. So PV is equal to nRT. I plotted the graph between V and T. And graph V I am getting the straight line. V I am plotting on Y. So this V I can replace by Y. nR by P into T. T I am plotting on X, so I can write as X. So Y is equal to mx. Because the straight line we are getting, so in the place of M, what I have? nR by P. In the place of slope, what I have? Slope is equal to what here I can write? slope M is equal to NR by P. Okay. Slope, I know that slope is the tan theta. That theta is the angle made by positive x. So slope is what? Tan theta we can write tan theta 1 I have given. So tan 45. That is equal to NR. Number of mole I gave 1 into R by P. Tan 45 is what? 1. So that you will get what? R by P. So from that P what you will get? R. Now volume you are using in meter cube. Okay. So pressure you will get in the MKS unit. MKS unit of R is what? 8.314. So 8.314 you will get in the Pascal. Understood or not? Okay. Okay. Now by that way we can use the slope also. Okay. Okay then. So this is the all about, like, now one thing is remaining, gamma of a gas. Okay. So now okay, so one simple, first you will say what is the basic formula of the gamma? What is the gamma formula? So gamma is the what, whether I am using for the solid or liquid. Basic formula of the gamma, arey ladke Vikram, 3 alpha. Gamma basic formula 3 alpha. How you can say? Alpha is only defined for, now new formula is coming. All the symbol, Abhiram, all the symbol does not have the same meaning. Gamma here I am talking about the thermal expansion, volume expansion coefficient. Okay. So gamma is the 3 alpha. That is only applicable for the isotropic solid. Alpha is we cannot define for the liquid and gases. So there is a no meaning of the alpha in the liquid and gas. So gamma basic formula is not the 3 alpha. Gamma basic formula is the delta V by V into delta theta. Delta, okay. And gamma that you are saying Cp by Cv, that is the adiabatic index and the adiabatic constant that we will learn in the adiabatic process. Okay. So gamma basic formula is the delta V by V into delta theta. So in any problem, if they have not given anything but we have the idea about the volume or change in volume, then gamma basic formula we have to, whether it is a solid, liquid or gas, delta V by V into delta theta. Okay. So like at constant pressure, find gamma of a gas. Again you will get find coefficient of volume, otherwise you will say Cp, coefficient of volume expansion of gas. That I will say. I'm not saying the chapter is getting over. So at constant pressure, find coefficient of volume expansion of a gas. Okay. So at constant pressure, so we know the first only we have the only one law, PV is equal to nRT. Okay. So for 1 mole. Now then I can say what? PV is equal to RT. I need what? I need the gamma of a gas. So basic formula of the gamma is what? Delta V by V into delta T. Okay. I am saying the constant pressure. So pressure is constant. So I can apply the delta on both sides. So what I will get? Pressure constant. So P into delta V or dV. That is equal to R constant into delta T. Or one mole is also not given. So no, it is not a problem. Mole and mole will get cancelled out. Okay. Up to this, okay? So suppose this is the 1, this is the 2. Mole has not given, so otherwise you can remove the mole, not required. Then here you will get NR, here you will get NR. Okay. I need the delta V by V into delta T. So just divide the equation 2 by equation 1. So delta V by V, what you will get? N cancel out, R cancel out, that is the delta T by T. Okay. Gamma, we know that gamma is equal to what? Delta V by V into delta T. Okay. From this, what you will get? Delta V by V. This delta T is shifted here. Then what you got? 1 by T. Yes or no? Everybody got? So gamma is equal to 1 upon T I got. If you remember, I said in a solid and liquid, gamma of the solid depends upon gamma. Theoretically, it does not depend on the temperature, but practically gamma depends on temperature for the solid. Liquid, it is independent of temperature. Now for the gases, what you are getting? If suppose I am asking gamma of the gas depends on, it depends, direct I cannot say inverse or that. It depends on temperature, but actually it depends on the process. It depends upon the, this solution or statement. Solution. What I am saying that at constant pressure I have to find the gamma of the gas. Gamma of the gas is delta V by V into delta theta. I have to write basic formula of the gamma, delta V, change in volume upon original volume into delta theta. So PV is equal to nRT. I am saying the constant pressure, so P is constant, R is constant, everybody know. So I am applying the delta on both sides. So pressure is constant, so only volume is variable, so P into delta V, P dV, like that. P delta V is equal to N constant, R constant, only temperature may be vary, so dt or delta T I am writing. So I got the P delta V is the NR delta T. Now gamma formula is the delta V by V into delta theta. So here delta V, here is a V. So what I can do, I can divide equation 2 by 1. So when I divided, I got delta V by V. This side I got delta T by D. Now this delta T I can shift in the denominator. Then I will get delta V by V into delta theta. That is the gamma of the gamma basic formula. So gamma is the delta V by V into delta theta. That I got 1 by T. Understood? So here from this gamma I can say gamma depends on temperature. And variation with the different equation, the variation will be different. Here I said the constant pressure. Maybe the different process it will follow. Okay. So I can say the gamma of the gas depends on the temperature, or it can depend the process. According to which process you are changing the volume on. Okay. Understood or not? So gamma of the solid depends upon the temperature. Liquid gamma does not depends upon temperature, and gas gamma depends on the process, or we can say it depends on the temperature. Getting my point or not? Okay. So this is the procedure you have to follow. Here directly I apply the delta because the process I gave the pressure constant. But in some cases, suppose you are unable to do so, that just differentiate on both sides and replace the d by the delta. Then you will get the formula. Okay. Okay. So next question you will do, if PV square is equal to constant, then find number 1, if volume of gas increased up to 4 times, then find ratio of initial and final temperature. And number 2, gamma of gas for given process. For the same gas, in a different process, gamma you will get different. For the same gas, if you are changing their volume at the different process, you will get the different gamma. So this problem, I have given the equation PV square is equal to constant. Okay, then we have to find first one, if volume of the gas increase up to the 4 times, then what is the ratio of the initial to the final temperature, and we have to find the gamma of the gas for the given process. Okay, now that you will try, next class I will discuss, or I have to discuss now? Tell fast. You need to discuss now. Okay, okay, now. Okay, so first I am saying the volume ratio of the temperature. I gave the volume, final volume is the 4 times, because the volume you have increased up to the 4. So first I have to get the VT relation. I gave the PV relation, but I'm asking that temperature ratio when the volume I have given. Okay. So volume and temperature I have to connect. So we can write the VT relation. How? So I don't need P because the data of the P they have not given. So I will replace the P in the terms of volume and temperature. So P I can write as from the ideal gas equation nRT by V. Okay. Then P I can replace by nRT by V into V square, that is equal to constant. Now 1V cancel out. So I got N into R is the constant. So I got VT is equal to constant. So means that process PV square I can write in the terms of V and T is what? VT is equal to constant. Now I am asking the ratio of initial and final temperature. From here you can say V1 T1 is equal to V2 T2. So T1 by T2 what you will get? V2 by V1. Now V2 final volume I have given 4 times of initial volume. Suppose initial volume is V. Then what you will get? 4. So T1 upon T2 ratio of the initial to the final temperature. What I ask? Initial to final temperature ratio what you will get? 4:1. Okay, 1:4 is the ratio of the final to the initial, but I am asking the ratio of the initial to the final. So I am asking T1 by T2. VO. Okay, so this is the answer is the 4. Now from this VT is equal to constant, I can find the gamma. How? VT is equal to constant. So what I said, for the gamma I need the delta V, delta T. I need delta V and delta T. So differentiate it. So when you differentiate, what you will get? First function into second differentiation, I am writing directly as a delta. First into second differentiation plus second into first differentiation. That is equal to differentiation of constant is what? 0. Okay. Product rule, I think everybody know, differentiation, product of two function. Okay. Now I need the, just shift this other side. So T delta V, what I'm getting? Minus V delta T. Now shift this V and delta T in the denominator, then you will get T into delta V by V into delta T. That is equal to -1. This quantity I can write as gamma. Now gamma what you will get? Gamma is equal to -1 by T. Okay. So in NCERT they have given for the constant pressure that gamma is equal to 1 by T. Okay. In the exercise, in the salt example they have given, and there they have said the gamma of the gas depends on the temperature. Okay. So next class one more problem I will discuss, and then I will discuss the conversion of the graph from one to the other. Okay. Okay, then bye bye. Sir, after exam, doubt class will be there for online student. Doubt class means paper discussion. Bye, sir, and then the question mark means you have to say the bye or not. Okay. Means in a bye also that there is a doubt. One girl is asking the doubt that, sir, after you will take the doubt after the test. Then one is asking, sir, bye question mark. Okay. If a delta V by V, delta T by T. No, sir. Yes, yes, yes. Okay. Delta V by V is equal to delta T by T. Yes. At constant pressure. Directly you can say. Otherwise, V directly proportional to T. So delta V directly proportional to delta T. After dividing, you will get the same relation. Okay. Bye bye.